Hello and welcome to our project. My name is Andrea Velazquez.
I'm Ochoa.
My name is Montiel.
The purpose of the following project is to investigate and then apply our knowledge in the solution of problems that implicate the next subject, solution of triangles and inverse trigonometric functions.
These are things that we've learned in class. In this project, we'll also present an introduction to the subject of fitting sinusoidal curves to data and how to apply them in related problems.
This project will also contain a section of theory, where all the key information and main ideas of the topic will be exposed with a brief explanation of how the present subject can be applied in the other context.
Okay, let's go to the theory part. Law of sines. The law of sines is a relationship of the sides of an internal angles and oblique triangles. It states that the length of a side of a triangle that divided by the sine of the angle opposite to that side equals the same for all sides and angles of a triangle. The formula of the law is A over sine of A equals to B over sine of B, and also equals to C over sine of C. This is the formula, and side C is opposite to angle C, side B is opposite to angle B, and side A is opposite to angle A. The law of sines work if you have two angles and one side, or if you have two sides and one angle opposite to one of these sides. Law of cosines. The law of cosines is also used to complete the solution of parts, sides, and internal angles of an oblique triangle. This law states that the square of one of these sides equals to the sum of the squares of the other sides, minus 2 times the multiplication of the other sides, times the cosine of the opposite angle. This is the formula of the law of sines. The law of cosines can be used in case you have 3 sides of the triangle, or if you have 2 sides and the included angle between those sides, that will be in this case B. The sinusoidal curve. The sinusoidal curve is the graphic representation of the trigonometric radial sine. This is the sinusoidal curve. I'm going to explain the next concept. Amplitude. The amplitude represents the height of the curve. In electrical voltage measurements, amplitude is used to mean the peak-to-peak voltage. This number will be twice mathematical amplitude. For example, you have here your curve. This is your highest point and your lowest point. So your median point is 0. Between 0 and the highest point, the distance is 1, and the lowest point is 1. So your amplitude will be 1. The period. The period represents like this curve will go on and never finish, and so this way. So your period will be this. It is like represents the cycle and the length of it. So our period will be 2 pi. The frequency. The frequency is the number of complete cycles that happen every second. The unit of frequency is hertz. This is used more in like sounds, waves, and that. The angular frequency. It measures the angular displacement per unit time. It is measured in degrees or radians per second. And your phase shift. The phase shift is the lateral difference between waveforms among a common axis. It can be measured in radians or degrees, depending the angular units used. The phase shift also represents the horizontal movement of the curve. So in this case, as this is the basic representation of sine, our phase shift is 0. So our function will be y equals to sine of x. Simple harmonic motion. The simple harmonic motion is symbolized by the motion of a mass of a spring when it is attached to a linear elastic force that is given by the Hooke's law. This motion represents a sinusoid in time and demonstrates a rational frequency. So the formula of the simple harmonic motion is y equals to a sine of w plus t, where a equals to the amplitude, w equals to the angular frequency, and t to the period.
The inverse trigonometric functions. They are the opposite of the normal trigonometric functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. They are represented with a -1 on the top of them, or arcsine, arccosine, arctangent. Inverse trigonometric functions input side ratios and output angles. This means that if you know the trigonometric ratio but you don't know the angle, you can use these inverse functions to find that angle. The domain for inverse sine is -1 included to 1 included, and the range is from -pi over 2 to pi over 2. The domain for inverse cosine is the same, -1 to 1 included, and the range is from 0 included to pi. The domain for inverse tangent is -infinite to infinite, and the range is from -pi over 2 included to pi over 2 included. The domain for inverse cosecant is from -infinite to 1 to -1, and then union with 1 to infinite. And the range for inverse cosecant is from -pi over 2 to 0, union 0 to pi over 2 included. The domain for inverse secant is from -infinite to -1 included, union 1 included to infinite. And the range is from 0 included to pi over 2, and then union with pi over 2 to pi. The domain for inverse cotangent is from -infinite to infinite, and the range is from 0 not included to pi not included. All these domain and range are only for one period of each graph. These are the graphs for each of the inverse trigonometric functions.
This project is a teamwork, so in that case, we need a process to have a good project. The priority is the organization. So first, we need to read the project and organize the data we are going to need. After, we have a distribution of the parts in the team. Why? So we can have the best results in the teamwork, because everyone have a work and is equitable. Then we need a collaboration. The collaboration it's for some of us. We need more help with her topics because are very difficult. For example, the parts of resolution of problems. After that, we need a feedback because all the team needs the concept of the project, so we can have a good condition for the next activity of the project. Then we need to check the project for having the best grade in the rubric and check all the points in the project. All are good, all are fine. Then we have the conclusions, which we are going to talk for the conclusions and the group conclusion. For the first section of the problems, we have a mobile, a topic. In that case, we have a situation for a person in a cinema, and the person want to know where is the best place to see the movie, and the person are going to decide this for this angle. This angle is the angle for visualization of the person. The person wants to have the bigger angle of visualization. In this case, We don't know the angle, but in the case is theta. So we're going to do this. In this problem, we have this image. We have the distance from the screen from the floor is 10 feet. Then we have the height of the screen is 22 feet. The distance from the wall to the first side is 7 feet, and the distance between the seats are 3 feet, and the distance from the floor and the eyes of the spectator are 4 feet. In that case, we have these two variables: the angle theta and the distance x. Is the distance where the person have the bigger angle theta. For the first problem, we have this. Show that theta is equal to arctan of 28 over x minus tan arctan of 6 over x. In that case, we have for this problem this structure. Okay, so now we don't have right now a right triangle, and it's not necessary, but it's the best option. So we're going to graph a line here. Now we have a right angle, and in that case we have a other angle. In this angle we're going to call beta. Okay, we have two angles now, angle theta and angle beta. In that case, so we can say, so having this new section, we can say this. We have two angles, angle theta and angle beta, and all the angle is the angle alpha. You can say that alpha. So for the first section, we can say the angle the tangent of theta it's equal to 28 over x. We can solve for this. Theta tangent is opposite over adjacent. So opposite, it's this, and if this, it's 22, but it's 28 in that case. We have this. The height of this is 4, and in this case is 10. So 10 minus 4 is equal to 10 minus 4 is equal to 6. So this section is 6 ft. Okay, so we can say then tan of beta it's equal to 6 over x. Why? It's the same because we have tangent is opposite over adjacent, so opposite is 6 feet over x is the adjacent. So if we know the angles theta and angle b, it's equal to the angle theta, the angle alpha. So alpha it's equal to alpha is equal to theta plus b. Okay, so we define it theta, tangent of theta and tangent of b, and if we sum this, we have theta. We have theta. It's equal to tangent of alpha. It's a total angle. But we need the grade. We need alpha. So we have arctangent of 28 over x is equal to theta minus the beta. So we have tan arctan of 6 over x, and that demonstrates this equation. Okay. With the explanation of the last problem, we have now used the subtraction formula for tangent to show that theta is equal to arctangent of 22x over x square x plus 168. In that case, we have the same structure, but in that case we have this formula: tangent of s minus t is equal to tangent of t over 1 plus tangent of s tangent of t. So we have the same structure. The angle beta, the total angle is alpha. The total angle is alpha, and the second triangle is beta. This angle is 90 degrees. This measure is 60 feet. With this equation, if we transfer the data, we have tangent of alpha minus beta, it's equal to tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. Okay, we're right in this new formula. If we substitute these values for the real values in this representation, we have this new data. We have the tangent of alpha minus beta is equal to 28 over x minus 66 over x, so the last formula, over 1 plus 28 over x minus 6 over x. So in this case we have this formula. If we add an x squared and x squared 2 for cancel this x, we have in the new formula tangent of theta minus beta it's equal to 22x. We can see we're going to approach it for the new formula over, it's important, 1 plus 168 over x squared 2. So we can multiply all for square 2 for cancel this. With these new values, we can get the new formula. So we can see tangent alpha minus beta is equal to 22x over x squared 2 plus 168. With this formula, we can get the angle theta. Only taking the arctan. In this case, we have the final formula. With the last demonstration, if we put arctan to calculate the theta, so we can say theta, the angle we are interested, it's equal to arctangent of 22x over x squared 2 plus 168. This is the last formula, and this gives us the value of theta. Okay, with the last formula in the last exercises, we have in this moment, if we take the formula and put it in a graphicator, we have this graph when we have this line and this line, we can see have an extreme asymptote and two asymptotes in y equal to 1 and y equal to -1. In this case, we can see the maximum point in the graph is 30. In this graph, the maximum point is 30. So the maximum point when the rate in the graph will be x equal to 30. And in this case, we have we substitute this in the formula, theta is equal to tangent, the arctangent equal to arctangent of 22 equals 22x over x squared 2 plus 168. If we substitute the formula, we have the best angle, the biggest angle is for the angle theta, it's equal to 32.00 degrees. And in this case, we have, if we go to the problem, the best place, the best row in this case is the row 3. The row 3. Why? Because we have in this case this row, and the person is here, and the distance between these are 7, and in this case, so in this case, with this information, we can see that, say, the angle theta is equal to 40.3200 degrees. Okay, in this case, we have the angle x, it's equal to 30 feet. So the best row for the best row in the cinema is the row 3. Why? Simple. Because we have the first section, the distance between the first row and the wall. In this case, we have 7 feet. So 30 minus 7, it's equal to 6. So in this case, we only have 6 feet free, and the space between it's equal to 4.3200 degrees. So, and the distance x, the best distance x is equal to 30 feet. So the best row for Z is the row 3. Why? Simple. Because we have the first section, the section between the first seat and the wall. In this case, we have the first section is 7, so 30 feet is the total between the total 30 minus 7 is equal to 6. So, and the distance between the rows are 3. So we only have 6 feet free, and 3 for 2 it's equal to 6. So we get the two spaces. So 1, in this case we have the first section, the first seat, we have 3 and we have 6. In this case is the row 3. Is the best place for the cinema.
So the second problem is the same measurements as the first one, but the only difference is that instead of the seats being in a straight line, these ones are inclined. So they're giving us that the inclination angle of the seats is 25 degrees, and this is called alpha in this problem. and we're also given the height of the screen, and like between the height from the highest seat to the floor is 10 feet from the bottom of the screen to the floor, and also that between each seat there's 3 feet, and that the height of the person is 4 feet. So first we're going to start by taking the measurements of this. We're going to make like this triangle here, and we're told that this angle is 25 degrees. So we know that this angle is x. We don't know the name of this angle or the measurement, so we're going to put like cosine of alpha is the adjacent or the hypotenuse, in this case x. So we're going to isolate the adjacent to know the measurement of this part, and we isolate adjacent and we get x cosine of alpha. So this part of the triangle measures x cosine of 25 or alpha. And now for doing this measurement, we're going to do with sine. Sine of alpha is opposite over hypotenuse. In this case, we're going to say that this is x, so sine of alpha is opposite over x. So we isolate opposite, and we get that opposite is x times sine of alpha. So now we know the measurements, the algebraic measurements of this triangle. So this part measures x cosine of alpha, and this x cosine of x sine of alpha, and this measures x. So now with this we can demonstrate that the formula of the law of cosines, which is that c equals a squared plus b squared minus 2ab times cosine of c, that in this case we're going to call it theta, and we're going to say that this side is a, this side is b, and this side is c. So in this case we know that c is 22. So now we're going to explain how each side for the formula. So with this we're going to use law of cosines, which is that c, in this case 22 squared, equals a squared, we don't know the measurements yet, plus b squared minus 2ab times cosine of c, that in this case is alpha. So now we're going to isolate alpha, and then we get that alpha is equal to inverse cosine of 484 minus a squared minus b squared over 2ab. So now with this we're going to get the measurements of a squared and b squared, so we can solve the formula. So now we're going to use this. We're going to draw a line here from the eyes, and we have a triangle up here. So we are going to get a. So to know the measurements of a, in this case we're going to use the theorem of Pythagoras, which says that a squared equals to b squared plus c squared. In this case we have b squared, this is b, so we know that the measurement of b is x cosine of 25 plus 7. This is b, this part here, and we know it because we measured this part and plus 7 that was gave to us by the problem. And now plus c squared, this is c in this case. So this part we don't know the measurement, but we're giving that all the height is 32. So we need to subtract this part of the height. So 32 minus 4 minus x sine of 25 degrees, that gives us 28 minus x sine of 25. So we have 28 minus x sine of 25 degrees. So we have here the measurement of a squared, or a in this case. So now we're going to use the triangle here on the bottom that we drew earlier, and we're told that this is B, and in this case is the hypotenuse, and we're going to use the Pythagoras theorem, and in this case is B squared equal A squared plus C squared. It's not the same variables as this, but okay, now we're going to say B squared is the sum of A of this squared to this squared. So this part we said before that measures x cosine of 25 degrees plus 7. So x cosine of 25 degrees plus 7 plus this side. So for this side we know that this part measures 10 and until here. So to know the measurement of this part of the triangle, we're going to use the height that we were given here. Then we take, so is x sine of 25 degrees plus 4. But we have one little space here that is missing from the lines. So we're going to subtract the 10 that are giving us from the height of from the screen to the floor. So we get that b squared is equal to x cosine of 25 plus 7 plus x sine of 25 minus 6. So let's remember that we're using, for doing this triangle and this triangle, we're using the theorem of Pythagoras. So we need to don't forget these squares. So this is squared, 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 squared. So now we have the measurements of A and B. So now with the data that we just made, we got this graph with a graphing device, and we were given that at highest point is 15, so x equals 15. So now with this, we're going to substitute in the formulas of a squared and b squared, and we get that a squared is equal to 893.3252, and a is equal to 29.8885, and b squared is equal to 424.0231, and that b is equal to 20.5918. So now we're going to substitute a squared, b squared, ab in this formula that we have here, that give us at the end that theta is equal to 47.3891 degrees. So now we're going to remember that between each seat in the problem it was 3 feet, and we got that x was equal to 15 feet. So if we divide 15 by 3, we get 5. So the best place to sit at the cinemas is in row 5.
For the second problem of the project, we have this table of data. With this data, we can get the values. If we take the values and put it in a graphic device, we can get this graph. In this case, with this dispersion graph, we can see the points in her respective place. With the last data and this graph, we have to find a formula with this form. And now with this graph, we can get the formula ft equal to 12.05 cos of 0. C minus 1.5 plus 30.05. This formula have the amplitude of 12.05, the period of 0.1, the vertical shift of 30.05, and the horizontal shift of 1.1. We can use this formula to grab a line that near the points and is this. You can see it's not perfect, but it's the near line we get with this formula. But if we get the last data, this graph, and put it in a graphic device, we get this formula. The formula is y equal to 12.96 plus 11.72 sin of 5.05 t plus 0.24. If we compare the functions with the reduction formula of sine u equal to cos u minus pi over 2, this formula, we get for the new formula y equal to 12.96 plus 11.72 cosine of 5.05 t minus 0.26. So with this we finish the problem 2.
Inverse trigonometric functions and sinusoidal curves can also be used in the production of music or sound. As we know, sound travels in waves and frequencies, so music is composed of waves and different frequencies and amplitudes, so they can be described using sine and cosine. Also, another use for trigonometric functions and sinusoidal curves is the use of the GPS, because the GPS systems use like a triangular connection with the satellite, so they can know the position of the device. Another application for trigonometric inverse functions is the knowledge of the waves in the ocean. So scientists can study these measurements that are associated with the waves and how they repeat, that is the frequency in this case, and how long they are, the waves, that is the wavelength.
After finishing this project, I was able to realize how important trigonometry is nowadays. It can be applied in little things and also in the calculation of major things. So it is fair to say that it is a tool for the human. Also, by researching the law of sines and law of cosines, I could relate it and understand better the subjects that we treat in class. It was very important to understand every concept in this subject so we can apply it in the problems required. This project helped me a lot with an introduction of the sinusoidal call and its composition.
The trigonometric is an important part in the life of a lot of people in the world and in a big number of professions. It is necessary to understand the world and explain the function of the elements in the life. The graph of the mathematics are the representation of this, and it's a really good instrument for the presentation of the data. The laws of sines and cosines are really interesting topic for a project, and it's a challenging experience.
By doing this project and researching about the different trigonometric functions and their inverse and sinusoidal curves, I became more aware that the use in our everyday lives for things like using the GPS systems or going one place to another or listening to music involve these trigonometric functions. So also they can help you to solve different exercises that we have.
As a team, we learned on how to use the different trigonometric functions and their inverse, and well as solving problems and building sinusoidal waves graph. We all agreed that the use of trigonometric functions and their inverse for solving math problems is useful, as well as for analyzing in real life.
Also, that these functions are presented in our daily lives, even so we can notice them as symbols.
Thanks to the concept that we learned in class, we can use all these functions to solve the problems, even though they are not as hard as it looks.